Scientists and astronomers are always on the lookout for the next big thing in space, and this time they may have found what appears to be one of the biggest structures ever to exist in the galaxy. The massive alien megastructure has drawn all attention skyward, and with its discovery has sparked researchers to think that it might not be the last of its kind. Welcome to Factnominal, and today we'll take a closer look at this strange anomaly and why its very makeup has left scientists scratching their heads. An incredible discovery was recently made by an international team led by the group of astronomers from the Max Planck Institute of Astronomy, otherwise known simply as MPIA, located in Germany. They were able to do so with some help from the European Space Agency's Gaia satellite. Located 55,000 light-years away from planet Earth, the megastructure is said to be some 16 trillion miles across. Researchers have estimated that the large filament could have been formed 13 billion years ago. The megastructure stretches out at 3,900 light-years long and 130 light-years wide. Seeing as how 1 light-year is equal to 9.44 trillion kilometers, it sure is a beast of a structure spread out across the Milky Way. That, however, does bring up certain key questions. Where exactly did this come from, and if it's so huge, how come we are just finding out about it now? The first clues about the structure were actually seen by the co-author Juan Soler a year prior to the actual study being conducted and published on 20th December 2021 in the journal Astronomy and Astrophysics. He fondly gave it the name Maggie in honor of the longest river in his own home country of Colombia, the Rio Magdalena, or the Magdalena River, which is quite fitting given how it stretches out across the Milky Way. In his own words, he has stated that Maggie was already recognizable in much earlier evaluations and data. But as we all know, space being so large and full of secrets, we really can't jump to conclusions. The observed structure of that magnitude could have been just about anything, as seen in the image taken with the help of the ESA's Gaia satellite. The box marks the exact location of the Maggie filament and the false color image of atomic hydrogen distribution. The entire study was led by Jonas Syed, a PhD student at the MPIA. Along with him was a diverse team of researchers from the University of Vienna, the Harvard-Smithsonian Center for Astrophysics, the Max Planck Institute for Radio Astronomy, University of Calgary, University of Heidelberg, Argelander Institute for Astronomy, and even the Indian Institute of Science and NASA's Jet Propulsion Laboratory. A true dream team studying the largest known structure in the Milky Way. It was only until the current study was conducted that we were able to prove beyond a doubt that this was in fact a coherent structure. The cloud was discovered by the team as part of the HIOH recombination line survey of the Milky Way, which also goes by the fun acronym Thor. We wonder if the Norse god of thunder himself would deem this megastructure worthy. The survey that led to the discovery of Maggie actually relies on all of the data that is collected by the radio observatory called the Jansky Very Large Array in New Mexico. Here, there is a constant scouring of the skies in hopes to find objects that lie outside of the main plane of the Milky Way, the flattened disk where most matter in the galaxy can actually be found. Leader of the study, Jonas Syed, stated, "The location of this filament has contributed to this success. We don't know yet how it got there, but the filament extends about 1,600 light-years below the Milky Way plane." Upon further analysis, it was found that the structure is a humongous hydrogen cloud. Thanks to the filament being located in just the right spot outside the plane, it was much easier to spot than it normally would have been. The radiation from the hydrogen is clearly visible in this area, which is how it was so easily detected, owing to the fact that there is hardly any real interference in that area. Due to the gas cloud being rather isolated, it also gave the researchers the advantage to calculate the velocity of the gas within Maggie. What they found was actually quite surprising. The research was based on data obtained by Thor, an observation program that relies on the Carl G. Jansky Very Large Array, or VLA, in New Mexico. With the help of the VLA centimeter wave radio dishes, the project studies molecular cloud formation, how atomic hydrogen converts to molecular hydrogen, the Milky Way's magnetic field, and many other areas of astronomy, including star formation. The process of how atomic hydrogen transitions to molecular hydrogen is still a mystery, which is what made this discovery all the more exciting. The largest known clouds of molecular gas generally measure around 800 light-years in length. So take that in comparison to Maggie and the impressive 3,900 light-years that it stretches out to. It grabbed everyone's attention. But all they needed to do was somehow make sure that this was in fact a large singular structure that they were observing. The analysis conducted by the team showed that the matter in the filament had a mean velocity of 54 kilometers, which they found by measuring it against the rotation of the Milky Way disk. This meant that the radiation at a wavelength of 21 centimeters, aka the hydrogen line, was visible against the cosmic background, thus making the structure discernible. Henrik Buther, the head of Thor and co-author of the study, stated that the observations allowed the team to determine the velocity of the hydrogen gas, which allowed them to show that the velocities along the filament barely differ, since the gas seemed to be moving in the same direction and same speed, which confirmed one of their initial doubts that it is in fact a singular large structure, and not merely a cluster of multiple clouds sitting together side by side. This was the confirmation that they were looking for before they could declare it the largest megastructure yet. Bringing back the hydrogen aspect that got everyone excited, Maggie is also garnering a lot of attention for the fact that it's also made up of a rather unique form of hydrogen. Hydrogen was formed about 380,000 years after the Big Bang took place, and is by far the most widespread substance in the entire universe, and it is the main ingredient in the formation of stars. What else do we know? We know hydrogen can be in two main forms: atomic hydrogen or molecular hydrogen. The first being just single atoms of unbonded hydrogen, while the latter consists of two hydrogen atoms bonded together. If you consider most of the hydrogen clouds in space, they mainly consist of molecular hydrogen. But Maggie is special. The large cloud structure appears to be made up of 92% atomic hydrogen. Only 8% of Maggie's hydrogen is molecular, and it seems to be concentrated into certain points along the cloud. Researchers are particularly interested in this aspect of the megastructure and searching for the reason behind its unusual makeup. However, there are certain concerns that have arisen as to the origins of the cloud. Usually, most stars are formed from clouds of molecular hydrogen that become dense before collapsing under the force of gravity. What scientists and researchers suspect is that the molecular hydrogen clouds may have once been made of atomic hydrogen in the past. But what they cannot seem to explain is how the atomic hydrogen clouds transition into molecular clouds. Studying this aspect of the Maggie filament could bring us all closer to understanding the formation of these megastructures, and even finding more that could be lurking beyond our Milky Way. The discovery of the Maggie filament was a great way to end the year 2021 on a positive, exciting note. Although its existence actually has resulted in a series of many questions, it sure holds the key to understanding structures of a similar nature. Jonas Syed himself stated that there are yet many questions that remain unanswered. Additional data is needed to give the team more clues about the fraction of molecular gas, a lot of which the team has already gathered and are waiting to analyze further. What's more, researchers are convinced that this isn't just a one-of-a-kind structure, and it just happened to be positioned at just the right place that they were actually able to detect and observe it. What about the ones that we do not see or are currently unable to detect? Well, the good news is that several new space-based and ground-based observatories will soon become operational, and telescopes are going to be equipped to study filaments in the near future. The James Webb Telescope and radiosurgery such as the Square Kilometer Array will be at the forefront of future studies to be carried out, and will bring us closer to understanding the early mysteries of our universe. So, what do you think? What are your thoughts about the Maggie filament? Let us know in the comments. Don't forget to smash that like button and subscribe to our channel so you don't miss a thing. Thanks for watching. We'll see you next time.